I want to get something out of the way, and just so we're all on the same page, and I can talk a little bit more freely without having to edit myself on the fly. All right, so what we're going to talk about here are units. All right. Let's investigate fractions really quick, okay? So, this is our scale. I'm going to say this is 0, and this is 1 inch. Okay? Fractions. What's half of 1 inch? Well, half of 1. Let's do that instead. We're going to call this a half. All right. If we divide our 1 whole into quarters, we end up with quarters. So that's 1 quarter, 2 quarters equals a half, and this is 3 quarters. I know, some of you are like, I know this already, I learned this in grade school, but just, all right. If we divide our whole into eighths, 1, 2, 3 eighths, 5 eighths, right? 1, 2, 3, 4, 5, 6 eighths, which can be reduced to 3 quarters, okay? We now have 7 eighths over here, all right? And we can keep going. We can divide this even further into 16ths. 1, 2, 3 16ths. All right? And we can keep, I'm going to erase this now. We can keep going. We can keep going for a really long time. However, what I'm going to do is if I divide by 16ths here, what we're going to start getting, we're going to get 30 seconds. 1 30-second, 3 30-seconds, and if we divide that into 64ths, now we're going to have 64ths of an inch. Okay, 64th. Typically, on a scale, or what is commonly known as a ruler, it's actually called a scale. You can't mark with even with a really, really sharp pencil any further than a 64th. You just can't. You just can't do it. Don't even bother to try. So really, trust me. I've been making stuff my whole life, and once it reaches 64ths, I'm like, nope, that's it. We're not marking that. We're going to measure that. And okay, so that's fractions. Now I want to talk about something else here. And we're going to talk about decimal places. Let's identify the places on this number. What's this place? This is tenths. This is hundredths. The 1 here, this is thousandths, and the 4 is 10,000ths. I know this already. I just want to make sure everyone's on the same page. And now I'm going to throw out some jargon. Okay? I'm going to call out 3 thousandths. 3 thousandths. 3 thousandths. See that? 3 thousandths. What? Because 3 is in the thousandths place. Now, you ready? Check this out. This is where it gets confusing. Verbally, I'm going to say, or when I read it in my mind, I'm going to say 423 thousandths. I can do this. 420 thousandths. I know. In math class, you were taught that the zero doesn't mean anything anymore. So this would be 42 hundredths. Remember, because this is the hundredth spot. But in machine shop world, most of the time we carry things out to the thousandths place. Now you will see numbers carried out to the fourth decimal place. I'm just going to write, say 5 here, to the 10,000th place. But let me put this into perspective to you. Anybody know how thick a piece of hair is? The diameter of a piece of hair is 3 thousandths. Hair is 3 thousandths thick. In the machine shop, we go to the thousandths place. That's how fine we carry our measurements. Yes, it is absolutely, totally possible on a machine to machine a piece of metal down to the thousandths place manually. Absolutely 100% no problem. Okay? Yes, it takes some practice, but it's not critical. However, as this tolerance gets finer and finer and finer, the part becomes more expensive. I'm just going to stop right there because that's a whole nother lecture. Typically at school here, unless it's absolutely a precise fit like a bearing or something like that, we want to be in this neighborhood. I am going to teach you how to machine, or I wish I could teach you how to machine on the machines, but I'm going to demonstrate. And after I would normally have taught you in lab, I would expect that you guys could land within 3 thousandths pretty much all the time. Okay? All right. And once again, 3 thousandths is a piece of hair. So let's talk about more of this here. Okay, so if I write down 100 thousandths, no, it's not 1/10. If it was 1/10, I would just write 1/10 in fraction form. Not really, why, right? The reason why I'm saying the word thousandths is because I care about the thousandths place. So if we're going to machine something down to 100 thousandths, I care because I might have a tolerance up here of plus or minus 3 thousandths. All right. So what's that mean? So that means this right here means that if I made a part and I measured it, if I measured it and it came out to 97, is that part still good? Yeah, it is. If it came out to, let's see, 102, is that part still good? Yeah, because we can be within 103 down to 97. So anywhere in between 101, 101 thousandths, the part would be good. 104. How about that? Recycle bin. Part goes to the recycle bin. All right? Okay. So typically around here, especially when parts come in without tolerances, or I'm talking to people and it's not that important, it's not a bearing fit or a shaft fit or something like that, I like to be within the 3 thousandths range pretty much on all my stuff. I think that's reasonable. It's reasonable for me, and it's reasonable for the person you know, who's gonna use the part, or, you know, part of their equipment or whatever, their contraption, whatever it is. Okay, I think this is reasonable. Please, if there's any questions, like I mentioned, just email me, and I'd be delighted to answer. And most likely, as you know, if you have a question about something, most likely I didn't explain it well enough, and everyone else does. So please, email me your questions. If you want me to go over that again, explain it in a different way, absolutely, 100%. I'm more than happy to do over and over and over and over again until you really understand. Okay, it's real important to me. All right, so let's change gears a little bit here. I'm not going to talk so much about fasteners right now. Okay, the different types of fasteners, which we will talk about, but I want to talk about threads, and I just want to give you a quick introduction to threads. All right. And real quick here, I'm just going to draw a bolt. So there's the head, comes around this, and then on that is some threads. We all know what this is. It's just a, right? All right. This threads, as we talked about before, has been standardized, these sizes. So probably the most common bolt in the world is what they call a quarter. What does that mean? All right. This is telling us two standards, okay? First of all, the 1/4 inch is giving us the OD of the threads. Okay, so this, I'm going to write OD, 1/4, okay? This 20 right here stands for TPI. Any guesses? That is threads per inch. That means that over the course of, say, 1 inch, there's going to be 20 threads. It doesn't mean that it has to be 1 inch. This could be a 1/2 inch, all right? And if it was a 1/2 inch, along that 1/2 inch, there'd be 10 threads there. If it was just a 1/4 inch, there would be 5 threads there, okay? It's 20 threads per inch, and that is the designator. So when you go to Home Depot or you go to the hardware store and you're looking through the bins and it says 1/4, 20, or another example, 1/2, 13, that's really common. 3/8, 16, okay? 3/8, 16, that's really common too. It's saying that's the diameter of the screw or the bolt, and it has 16 threads per inch. This has a 1/2 inch diameter, okay? And it has 13 threads per inch. That is how it's been categorized. Pretty simple. Okay? Let's look at threads a little bit more in detail. So now we have threads here, and it's our bolt. All right, it's our bolt. There's our bolt. Wait a minute. There we go. There's our bolt. All right. The technical terms for threads. If you look in the machinery handbook and you look up thread nomenclature, all right, it's going to give you a diagram, and when you open up on that page, you're just going to be like, bam, there's going to be like lists everywhere and all this nomenclature. Nomenclature is like, vocabulary. It's names that they assign to certain things, okay? That's what nomenclature means. You're going to be like, whoa, there's stuff everywhere. I'm never going to know all this, and you know what? You don't need to. That's what the handbook's there for. You don't need to memorize it. There are 2 or 3 things that I want to show you that you do kind of need to know, okay? And it's the jargon, so we're going to talk about that right now. I'm just going to label this stuff, okay? Here we go. The OD, so if we take a quarter 20, right? Quarter 20, the OD, which I called earlier, actually is not called an OD, all right? It's called the major diameter. By the way, that's the shorthand for diameter, like a 0 with a line through it, all right? That's the major, the OD is the major diameter, all right? What's down in the valley here, what do you think that might be called? You guessed it. It's the minor diameter. All right? So aside from knowing that the diameter a quarter and the threads per inch is 20, that you need to know. I think if you're going to work on your house, or I mean, you need to know this. Okay. In machine shop land, we need to know. I don't think you can see that. Quarter 20. Remember, quarter is the OD and 20 is the threads per inch. You got to know that. The OD in the machinery handbook is called the major diameter in manufacturing land. And in the valley, right in here on the bolt, that's called the minor diameter. Okay. Thread angle, the angle of the actual thread is about 30 degrees. So that's where we're going to stop. Okay. That is the same for a bolt or a nut. Okay? Just that the nuts, it's the same thing. It literally is the same thing. We would just do this. Okay? That's still the major diameter, and this is still the minor diameter of a hole. Hole. Let's talk about holes for a minute. There's 2 types of holes. There's one, and there's another one. Now, if you notice, one goes all the way through, and one does not go all the way through. And you can even see I drew in the drill bit tip down here, because that's what it would look like if you sliced it in half. It's pretty simple. This goes all the way through. It is called a through hole. All right. And this hole that does not go all the way through is called a blind hole. Can't see through it. Doesn't go all the way through. It's blind. Get it? All right. So those are, I mean, there's other types of holes. There's hold on, Blake. Okay, but right now, this is what we got. Through hole and a blind hole. Now, in our through hole, we want to make threads to accept a screw. So we're gonna make threads in here. Cut threads. How do we do that? So now, this is what we're going to end up with. How do we make threads? We use a tool specifically for thread cutting, and it is called a tap. Okay? So, down a tap is what's used to make internal threads. There it is. You guys, this is one of the most important things. It's here. It's just holes and taps, they're here. You can have a thread any size you want, all right? You go specifying some crazy threads, it's going to cost you a fortune, all right? You got to have the right size tap made, you have the fasteners made. It's right here. It's in the machinery handbook. It's right here on this chart. Tap drill sizes, all right? Thread drill. Let's just look at the thread column really quick. We can go down. Oh, look, quarter 20. We've been talking about that. That's probably one of the most common screws in the world, in standard, not metric. We go. Look, there's half 13. Remember, it's 3/8 16. All right. You might be saying, "Oh, why are there two, quarter 20 and quarter 28?" All right. One is the coarse threads, and the other is the fine threads. So it's still the same OD. It just means that there's 28 threads over the course of 1 inch. So what's that mean? There's more threads. The pitch, the thread itself is going to be finer. There's more of them. Yes. Okay. Now, if we look at the tap here, you're going to see that it doesn't cut right at the tip. Okay, it only cuts along the side here. Okay, and it looks like a screw, only it's designed to cut. So what we have to do is we have to drill a hole first before we use this tap. What size hole do we use? Well, we could figure it out without looking at the chart if we wanted. The chart's much easier. But what if we know that this right here is our major diameter, major diameter, and this inside right here is our minor diameter, we need to drill a hole the size of the minor diameter or real close, okay? So, but instead of measuring our screw to find out, or whatever we're doing here, we can use this chart. And all drill charts have on somewhere, sometimes it's interlaced in here, but they have what's the tap drill sizes. So if you look down here, you're going to be using a quarter 20 tap. What size hole do you drill? You just look right over here and it says, voila, number 7. You're going to do a half 13 hole. Okay, you can see half 12, half 13. 12s don't really, hang on. Half 27/64 is the size drill bit you're going to drill first, and then you use the tap to make the threads. Okay, and you can see here, quarter 20, number 7. Number 7, there it is. 201. That's the diameter of that drill bit. All right. Okay. On a side note, just real quick, number 12, 1224, and 1228. Typically, even though they're on the charts and pretty much in industry now, that's not used very often. Okay, I'm just going to let you know. As a matter of fact, it's tough to even, you can order this stuff, like you can order it, no problem, but you're not going to find number 12 hardware just like laying around anywhere like you would everything else. Okay. Also, the half 12. I typically don't see that very often. But everything else, definitely all the time. All the time. I'm trying to think if there's something else on here. No, it's those two. The 12s and the half 12. So you can think 12. You don't use that very often. Okay, so that's taps. We're not done, but that's the basics. All right. So what I have here is a set of taps. And I'm going to see if you can see that. And I have them arranged. And if you look closely at the tips, I'll draw it. You can see this one here is the taper and that's what it's called. It tapers very gradually as it's cut. The next one doesn't taper quite as much. This is called a plug tap, okay? And then this one doesn't taper very much at all, actually, even just a tiny bit, all right? It's called a bottoming tap. All right, you ready? So we drill our hole, and then it's time to tap. You always start with the taper tap, the one that tapers the most, okay? The reason is if I try to start with a bottoming tap, two things. As I drive this by hand through my hole, it's really aggressive. It's trying to cut the full thread. And what that's going to do is, well, definitely over time, it will break one of these teeth. It's too much to cut all at once, all right? We need to do it gradually. And that's why we use this taper tap, okay? Now, with a through hole, it's not that big of a deal. Let me erase this. Especially with a taper tap. Because the taper actually helps it not go crooked too. So when you're doing it by hand with a taper tap, because it's gradual, it's going to self-center itself. It still is easy to go crooked, don't get me wrong. But it helps, and it helps to self-center itself to keep it from cutting. So you have like an outer round threaded hole. Helps it go down, and it doesn't cut as aggressively because it's tapered. The other thing is, you notice these flutes, like the drill bit, remember the flutes and the drill bit are designed to eject the chip out, right? Out. Well, these flutes are straight. And really, these flutes are just to help sharpen and give a place for the chip to go. Where does the chip go? On most taps, they make them that the chip comes up and they have spirals. They have flutes in them, okay? But on most general purpose taps, the chip goes down. So as you're cutting, you're going to get a chip or, right, chip that goes down to the bottom. Now on a through hole, that's not a problem because they just, they just pop right out the bottom. We're good, okay? On a blind hole is another issue. So here's our blind hole that we want to put threads in, right? Okay. Well, that's the purpose for the bottoming tap. The bottoming tap has full profile threads almost all the way to the bottom of the tap. So that way, when we put the bottoming tap in, it's going to give us threads almost to the bottom of the hole. Now, it doesn't mean you start with a bottoming tap. Whether you're tapping by hand, when you're tapping by hand, you need to go through the tap. So you're going to start with a taper. If it goes all the way through on a through hole, you're done. Okay, but if it doesn't, because it's not long enough, you go in with the plug tap, and then you finish off, well, only on a blind hole with a bottoming tap. And that's what the bottoming tap is for. The bottoming tap is to get threads all the way down to the bottom of a blind hole. Okay. Now, let me draw that really quick so it may make, I think it's pretty clear, but we're going to have a really long taper. This is the taper tap. We're going to have less taper. I think you can see that. This is called a plug tap. And then we're going to have very little taper, actually. Just like that. And this is called a bottoming. And once again, the bottoming tap is for blind holes. It's not for through holes. Okay. Those are the 3 types of tap. I have another one here since this is a spiral point tap. I personally use these mostly unless I need a bottoming tap. They really self-align. I do a lot of tapping on the machine too, not by hand. And when I have a through hole, these are a delight. They're a spiral tip. They're also known as a gun tap, and that's because of rifling. But we're not gonna. No gun talk. But that's what they are known. They're slang as a gun tap. But it's a spiral tip tap. Here's one. This one I believe is 3/8/16. So you can see that right there. Okay. All right. Now, a tap once again is to make threads in an internal hole. What about threads on externally? Okay. What we use to do it by hand is what's called a die. And this is a die, and if you look closely, you can see that there's thread cutters in there. Okay. It's held in this handle. A lot of people call it a handle. That's not what it's called. It's called a die stock. That's what it's called. It's called a die stock. And there actually is a right way to put this die into the die stock. But first we need to look closely, and you can't see inside on camera, so I'm just gonna draw this really quick. Inside that die, as opposed to a tap, you can see there's lots of cutting edges on a tap. There's not so much cutting edges on a die, which is a huge problem, actually. But if you look closely on the inside of that die, you're going to see it looks kind of like that. Same with the others. That taper part is only 1 or 2 threads, and then it's flat on the bottom. So one side, it's like that actually. Imagine. It's tapering in, but just a little bit. Often you'll see, not on this one, but it'll say start this side, okay? Because that's the side that gradually cuts. So when you put this into the die stock, you're going to notice on this die here that there are a little indentation here, and then at 180 degrees on the other side there's an indentation. But then there's 3 set screws on this die stock. See those 3 set screws right there? And oh, the one in the middle is pointed. See this? I think you can see that. See how it has a wedge in there? All right? The pointed set screw, which is going to be really hard to see on camera. The pointed set screw, I think you can even see that. There it is. Goes in that wedge. So let's see here. So this is the gradual side. We drop this in here on that wedge, like so. Okay. And then tighten up these set screws. They don't need to be tight. They just need to stop it from spinning inside. And this, right? That wedge keeps the die from crushing on itself. Because if I were to tighten these set screws up too tight, I could make the die smaller. I don't like to use dies just to make threads on a piece of bare rod. It typically tears up the material. You don't get nice threads. It even makes it not even straight anymore because there's so much forces in the cutting. I like to do a little bit of threading on the lathe first. I know, I went way there. But you don't worry, you're going to see that anyway. Okay, so the tool to make external threads, which believe it or not, we don't use very often, is called a die. So external threads, is called a die. Okay? So, real quick here, and then I think we're done. There's a couple details that I want to go over. First of all, on any threaded hole, internal threads, you got to do what's called a countersink. And there's a couple reasons for that. And let me show you what I mean, because I have it right here. This, it's a big one, is a single flute countersink. So it's going to, before I put the threads in, right, there's my hole. It's going to cut off, sheen off that right there. All right. All threaded holes should have at least the side where the screw goes in countersunk. There's two main reasons. I'll just cut to it. Number one is it looks good and professional, and you've cleaned you look like you cared, and it looks nice. The other reason is because the thread cutting is actually so aggressive. I know you don't think of it, but it really is quite aggressive. Is that the initial thread has a tendency to kind of lift itself up, and you can feel it, the burr right there. All right, but yeah, so we just countersink it right off, or we can countersink first, and when this lifts up, that first little bit right there, it's still below the surface. Okay, this is a single point countersink. The countersinks at Home Depot, don't even buy. They're junk. No, I'm sorry, they're just junk. Especially with aluminum and wood. You really got to know how to use them. There's so many tricks. But if you use a single flute countersink at a really slow RPM, and I mean slow, I'm talking 80 RPM here. So single flute countersink, single flute countersink, countersink at, I don't know, I'm 80 to 150 RPM. You're going to end up with a nice clean hole. Okay, we're going to talk about this angle and more detailed about countersinks in the future when we discuss hardware. Here's another one, and this is a 4-fluted countersink. I don't use it. I like the single flutes at a really slow RPM with aluminum, and even steels and slow RPM too. They don't chatter. That's kind of where I was going. I couldn't grab that word, but there's a lot of chattering going on with countersinking, especially from the ones you buy at Home Depot. All right, and I would of course say, are there any questions? But I can't do that. That's it for this one, and I will see you next week. Awesome. Thanks. Bye.